Hamiltonian says, suppose this Hamiltonian, now if you just see somewhere Hamiltonian means in your higher classes, if you see, if somebody says your Hamiltonian means Hamiltonian operator is given by h cap, here h square by, so means for any function you have to multiply h square by 2m delta square plus vr anta multiply ಮಾಡಬೇಕು. If they says that Hamiltonian anta, for any function you have to multiply with this number, that then it is called as Hamiltonian. So to simplify this, h square by 2m dou square by dou x square plus dou square by dou y square plus dou square by dou z square, dou y square, dou z square here plus vr. So suppose if they say that operate Hamiltonian on a wave function, then that means h psi is equal to, now just you have to write it here Hamiltonian, this is a Hamiltonian and your wave function is this. Okay, this is a eigen functions. Now this, how do you write this eigen function here? Now suppose, now if a is an operator, I can just write it a cap operating on a wave function psi of x anta ankoda, multiplies latter by a constant lambda. So that is, now a cap psi n of x is equal to lambda n psi n of x. Okay, so why? Because so psi is called as a, this psi is called as eigen function of a cap belonging to the eigen value one second. In class ನಡೀತಿದೆ, ನೀವು ಗಲಾಟೆ ಮಾಡಿದ್ರೆ. So I can just say that, so belonging to the eigen value. So now eigen value, I can just say that some eigen value we don't know, we can say that it is lambda. So if there are set of values, I can just say that, as I said that their set of values are represented by this, and this equation I can say that eigen value equation. What is it called as? Eigen value equation. For example, now I can just say that, suppose you consider a cap is equal to double differentiation d square by dx square, and psi of x, your wave function is represented by a e to the power of minus 2x anta ಅನ್ಕೊಳ್ಳಿ. Then I can just say that a cap psi x andre, I can just write d square by dx square a e to the power of minus 2x, which is equal to 4a, because double differentiation ನೀವು ಮಾಡಿದ್ರೆ your answer ಬಂದ್ಬಿಟ್ಟು 4a e to the power of minus 2x ಬರುತ್ತೆ. So ಅವಾಗ I can just say that e cap psi of x is equal to 4 psi x, 4 psi of x. See here, a cap psi n of x, lambda n psi n of x. Now your lambda is what? Lambda n is constant, that is 4. See, ಯಾವ equations ಈ ಫಾರ್ಮಲ್ಲಿ ನಾವು ಬರ್ಕೊಳ್ಳೋಕ್ಕಾಗ್ತದೋ, that equations are called as, that functions are called as eigen functions. So here for this example, psi of x is your eigen function. Psi of x is eigen function. Psi of x is eigen function. Okay, and the operator is what? D square by dx square. 4 is your eigen value. 4 is your eigen value. belonging to the psi of x. Okay, understood? ಅರ್ಥ ಆಯ್ತಾ? ಐಗನ್ ವ್ಯಾಲ್ಯೂ ಅಂದರೆ ಏನು, ಐಗನ್ ಫಂಕ್ಷನ್ ಅಂದರೆ ಏನು ಅಂತ ಅರ್ಥ ಆಯ್ತಾ? ಆರ್ ಶುಡ್ ಐ ಎಕ್ಸ್ಪ್ಲೈನ್ ಇಟ್ ಅಗೇನ್? ಡಿಡ್ ಯು ಗೆಟ್ ಇಟ್? ವಾಟ್ ಈಸ್ ಐಗನ್ ಫಂಕ್ಷನ್ ಅಂಡ್ ವಾಟ್ ಈಸ್ ಐಗನ್ ವ್ಯಾಲ್ಯೂ? ಡಿಡ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್ ವಾಟ್ ಈಸ್ ಆಪರೇಟರ್? ಅರ್ಥ ಆಗಿದೆಯಾ? I just need a confirmation. Did you understood what is eigen function andre enu, eigen value andre enu, what is the meaning of the operator? I am not able to see any responses. ಅರ್ಥ ಆಗಿದೆಯಾ? ಸುಮ್ಮನೆ don't say that blindly. Did you understood or not properly? You ask. If you don't, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದರೆ ಮತ್ತೆ ಇನ್ನೊಂದು ಸತಿ ಕೇಳಿ, I will explain it. So here, as I said that, so I have just explained here. So E is equal to NH square. This is a n square h square 8 ml square here. This is your eigen value, I said. So now what is eigen function and eigen value? To understand, the eigen function should have a single value and it should remain everywhere constant, and the first derivative with respect to their variables are continuous everywhere. Now, so I said that in quantum mechanics, as you know in your mathematics daily, there are some operators. The specific type of operators, see, there are many operators in your mathematics, but here in specific type of operators are present in the quantum mechanics, so that are formed by the set of rules of quantum mechanics. So now those kind of operators are position operator, momentum operator, energy operator, Hamiltonian operators will be there. And those operators, if you just apply for a wave function, well behaved wave function, we get, I said it here, for a wave function psi, if you apply an Hamiltonian, that looks like this. The solution, that is a later part, we'll worry about it. But in general, an operator for a wave function psi is represented by a cap, where a cap is a operator here for a wave function psi n of x is equal to eigen value, that is lambda nx psi n of x. Any values, any function which can be written in the form of a cap psi n of x is equal to lambda n psi n of x, that function is called as eigen function anta karitini nanu. I can call that as eigen function. ಇದನ್ನು ನಾವು ಐಗನ್ ಫಂಕ್ಷನ್ ಅಂತ ಕರೆದ್ರೆ, now where a cap is eigen function of a cap belonging to the eigen value, and this equation is called as eigen value equation. To understand this, what is eigen value equation, let us consider your operator as d square by dx square. Psi of x is a e to the power of minus x. Now d psi by d, that is d by dx of psi will gives you 2 minus 2 a e to the power of minus 2x. D by dx of, that is d square by dx square of psi will gives you 4 a e to the power of minus 2x. Now what is your constant? Your constant is 4. This is called as eigen value. D square psi by dx square is equal to, now I can just write it here, this one, a e to the power of minus 2x is nothing but your original value. So now I can just write it as a cap psi n of x is equal to, your lambda is what? 4 a e to the power of, that is 4 of psi x. Any functions, any quantum mechanical functions which can be written in this form, a cap psi n of x is equal to lambda n psi n of x,